Here's a question. Does filament expire? If you've been 3D printing for a while, you've probably been there looking at that sad little roll at the back of the cupboard and wondering, is that filament bad now? Will my prints suck if I use it? Well, I wanted to find out, so I dug through the Maker's Muse archives and found this roll of 7-year-old ABS. And I'm going to take this and all of these ancient spools and see if they still print and if this thing can revive them. Let's get started. How's it going, guys? Angus here from Maker's Muse. Before we begin, I want to establish the aim of this video. I want to try a range of old filaments that have been exposed to the air and see how that's affected their quality for 3D printing. On top of that, I also want to see if that damage over time, if any, can be reversed by using one of these, a cheap food dehydrator. I've heard that these are all the rage right now for drying filaments, so I'm keen to find out what result it has. I do need to stress though that although these filaments have been exposed to the air, they have not been exposed to sunlight, dust, or any other chemicals. They have mostly just hung around on the shelf in the garage for years in some cases, with no bag of desiccant to protect them from moisture. Oh, and also, as with all things, your results may vary. This is just my findings on the filaments that I have. To conduct my tests, I wanted a range of the most common plastics, starting with ABS. I started my 3D printing journey printing ABS exclusively, and I needed a specific color for a project back in 2013. So I bought this roll of neon green from 3D Printing Systems, the same company that my original Up Mini came from. Remember when filament came on these crappy cardboard rolls? I like the idea of sustainability, but damn did they suck. The filament was decent though, if I remember correctly, so let's see how it goes. Next up is PLA. I have this roll of clear PLA from 2015, and it's seen a lot, from creating a 3D scanned zombie version of my head for Halloween, to being spray painted and then printed to create crazy colored prints. Good times. This roll of nylon from early 2016 is ultra waterlogged and definitely a filament that comes to mind when people say that filament goes bad. I actually keep it on hand to use that moisture intentionally to steam clean nozzles to remove gunk. This is actually a tip from my 50 3D printing tips and tricks book, and it actually works really well. PETG is a filament I don't print very often, and this roll is only a year old, so I threw it into a bucket of water for a week. I did the same with this sample of hips, so if it's ever going to become waterlogged, now it is. Finally, this sample of PC, polycarbonate. This dates back to 2014 when suppliers would send samples to the studio I worked at in the hopes that we would order tons of rolls, and it's pure PC, no modifiers, which commands a crazy high printing temp of around 300°C. And it gave me a little bit of trouble, as you'll soon see. All but the PLA was printed on my Up Mini 2, and I jumped right into the deep end with the 7-year-old ABS and the Geyer Anderson cat print from Scan the World Initiative on my Mini Factory. And here it is, 7 years later, and it might as well be a new roll. The print looks great. ABS tends to struggle a little with fine details, so the ears and the underside of the face are a little rough with some tiny strings, but yeah, awesome. Case closed then, right? Haha, no. To convert my food dehydrator into a filament drying beast, I simply cut holes in all but the bottom shelf and chucked the ABS in for a good 5 hours or so. More expensive units do have temperature control, but this cheapo thing just has a 150 or 300 watt setting. So if the ATO is watching this, then yes, I do claim some of my electricity as a business expense because I had this stupid thing wasting power all week. Next up was PLA, and I printed this cat on the Prusa Mark III. It's a really nice clear PLA, but that does make it somewhat difficult to see print quality, but really, it's pretty clean. Something PLA does seem to do, however, is snap if left loaded in the extruder. I've had this happen with a range of PLA rolls, new and old, and I'm not really convinced it's linked to the moisture content, but rather to do with strain relief. But if you know why it happens, definitely let me know in the comments below, because you can actually see stress rises in the clear filament. Really interesting. Next up is PETG, dripping wet from the bucket. Apart from a small paper towel to wipe water off as it went into the extruder, it's as wet as it could possibly get. Interesting side note, this is the first PETG print I've ever done on the Up Mini 2, and I decided the cat wasn't the best test model at this point, so instead I went to choose the thicker leg variation of the bucket of octopodes on Thingiverse. This print went really well with no warping or under extrusion, but there's definitely room for improvement here. The print is a little blobby and there's a few strings too. Many people report this sort of finish when printing PETG, so maybe all I need to do is dry it. Oh, I also broke his little leg off pulling it off the print bed, it snapped a lot easier than expected. And now time for a filament famous for its moisture absorption, PA, polyamide, or commonly known as nylon. I actually don't know what kind of nylon this is. It was a role given to me. It just says EPA, but the moisture content is instantly apparent when extruding it, and it visibly and audibly bubbles and spits as it extrudes. And the print looks absolutely terrible. Strings for days, they're still pretty tough, but they have this super milky look from the moisture boiling off, and I really am hoping it can be recovered using our bargain basement food dehydrator. Next up is hips, another filament I'm not hugely experienced with, and I only had a tiny sample to work with, but it's from 2015, so I chucked it into the bucket of water with a PETG for good measure. Hips, or high impact polystyrene, has similar printing properties to ABS, and to my surprise, again, it printed perfect. In fact, this print has a really nice matte black finish. Super cool, and I can't fault this print. No blobs, strings, discoloration, or under extrusion. I didn't even bother drying this one, considering it printed like this while still physically soaked, so that's pretty neat. Finally, we have PC, polycarbonate. This filament is a real challenge to print with, and it's probably why companies often alloy it with other polymers to make it easier to 3D print with, and I can see why. Extruding did exhibit a little bubbling, but less than expected for something that's just had no protection for years. But to get it to print properly, I had to extrude at 300 degrees C. This test was done at 275 degrees C, and it's delaminating. So 300 degrees C was what we needed to print it properly, but the Pour Up Mini 2 bed just can't get hot enough. So the sample warped. Other than the warping though, the material looks to have retained much of its clarity, and it's also incredibly strong. Alright now, taking all bets. There is so much conflicting information out there on the requirement and effectiveness of filament drying, and as someone who has literally never had to bother doing it for day-to-day printing of ABS and PLA, I've always been more than a little skeptical. So let's start with the ABS result. The same. Yep, 5 hours in the dryer and there's no visible change to surface quality, color, or print quality. I honestly can't see any measurable difference in the two prints. In fact, this was so overwhelmingly disappointing that I found another old ABS roll, this gross brown from 2015, and I left it in water overnight. And here we have the test results from before I put it in the water and after I put it in the water. None of these were dried. The physically wet filament did result in a few tiny blobs on the print, but no idiot is going to feed like dripping wet filament into a 3D printer normally. ABS drying, at least in my tests, don't bother. Next up was a PLA. I put it into the dryer and well, PLA softens at a very low temperature, and before I knew it, the filament was very pliable. Even at the 150 watt setting. Remember, PLA can soften and deform just by leaving it in your car on a hot summer day, so I kind of ruined it. The print had areas of under extrusion and the leg fell off. And I think this is just purely due to the heat ruining the accuracy of the filament and nothing to do with moisture. So don't put your PLA in a hot area. I can't really recommend it. PETG though, on the other hand, was really interesting. After spending 5 or so hours in the dehydrator, the resulting print is visibly improved over the original. It's actually really cool how much of a difference it made. Remember, my PETG was actually underwater for a week, but if you're struggling with tons of strings and blobs on your PETG prints, maybe give the dehydrator a shot. I'm pretty stoked with how clean the improved print is after drying. Okay, it's nylon time. I dried this filament for ages. Some websites even suggest 12 or more hours. I just did it overnight, and the difference was astonishing. Even during the filament purge, you can see it coming out as a perfect water clear extrusion with no bubbling whatsoever. Now, the print does have a few small blobs, but the stringing is gone and the part is less milky, albeit still opaque. It's difficult for me to quantify if the print is actually going to be any stronger now because I'm not CNC Kitchen, but from a print quality standpoint alone, yes, 100% dry your nylon filament before use. And actually what I did is I punched a hole in the side of the dehydrator with a PTFE tube and I just left it on running straight into the 3D printer, which I would recommend because nylon is so hygroscopic that it absorbs moisture within hours. And that's always been my issue printing with it. And it's really pretty cool knowing that despite the fact that nylon has been ruined for 4 years, that it can still be restored with so little effort. Definitely get a dehydrator to print your nylon and stop it from looking like this and turn it into looking like this, and probably even better if I leave it even longer to dry out. As mentioned, the high impact polystyrene HIPs printed great without any drying after being underwater, so I didn't bother, but the polycarbonate was a bit of a different beast. I did see a little moisture in the purge extrusion before drying, but nothing near what the nylon was producing, and the prints looked identical before and after drying, both warped. But I don't want to call this one yet because I can't get a successful print off it on the Up Mini 2. The bed just simply doesn't get hot enough. If you have any experience printing with polycarbonate, pure polycarbonate that is, with like the 300 degrees C printing temp, please let me know in the comments below, and let me know if you do bother to dry your filament. So there you have it, guys. If you have a roll of 7-year-old ABS lying around and it's not dusty or UV damaged, give it a shot. It's probably fine. Same goes for PLA or HIPs. And if you print in PETG or nylon, then definitely pick up one of these dehydrators. I'll have some affiliate links in the description because they're super cheap and I really can recommend them. Even the cheap ones do a really good job. At least they did for me. If you found this video useful, then maybe consider subscribing to Maker's Muse, where it's my aim to empower your creativity through technology. And I look forward to seeing you again very shortly. Catch you later, guys. Bye.